evaluate the integral cos 2x exponential 2x dx. So here you can see this is a product of two functions, the trigonometric function and expression. So we use integration by parts. All of them are circulating, isn't it? So when we reach where we can get cos 2x exponential 2x, then we collect the like terms, isn't it? Are we together? So this one is UdV. We let it to be UdV. So our U is cos 2x. So if you differentiate cos 2x, if you differentiate cos 2x, you get negative sine 2x, isn't it? Then if you differentiate 2x, you get 2. So it is negative 2 sine 2x dx, isn't it? Are we together? Yeah, if you have u is equals to cos 2x, you differentiate u with respect to x. If you differentiate cos 2x, you get negative sine 2x. Then you differentiate the inner function 2x, you get 2. So negative sine 2x times 2, you get that. You take dx, the other side, you get du is negative 2 sine 2x dx, isn't it? Yes. Then you move to dv. So dv here, on this side, dv is equals to exponential 2x dx, isn't it? But we want v. We want v. So what is v? For us to get v, we introduce integral on both sides to remain with v, isn't it? So if you integrate exponential function, it remains the way it is, isn't it? Yes. It remains exponential 2x, then you divide by the derivative of the inner function, which must be a constant, isn't it? So derivative of 2x is 2, you divide by 2. That derivative of the inner function must be a constant. So we now have, when you have integration by parts, you know if you are integrating u dv, you're supposed to get uv minus integral over vd. This is the integration by parts. So let us go back to our problem. Cos 2x exponential 2x dx. This is u dv, meaning this is u dv. So when we have u dv, we are supposed to get uv, isn't it? Are we together? uv, that is u times v, this times this, isn't it? You get a half cos 2x exponential 2x. If you multiply u and v, are we together? Yes. Then it is minus vd du. So minus v du, v is this, du is this. So if you multiply this by this, 2 will cancel with a half, isn't it? Are we together? You remain with the sine negative sine 2x exponential 2x dx. Is that okay? So that negative, if you factor it outside, it changes that sign to positive, isn't it? So we have sine 2x exponential 2x dx. If you multiply v du, v is this, du is this. So this times this, 2 times 2, half is 1, then negative sine 2x exponential 2x dx. So negative, and this negative changes the sign to positive, isn't it? So from there again, it means this is now what we are integrating, isn't it? You bracket what you are integrating before you integrate it. So if you bracket that, so it means it is also a product of two functions, u dv again, isn't it? Are we together? So here you can see x sine 2x is u, exponential 2x dx is dv, isn't it? Is that okay? So go again. You found a sine 2x. So if you differentiate u with respect to x, if you differentiate sine 2x, you get cos 2x. You integrate the inner function, you get 2. If you differentiate 2x, isn't it? So differentiating sine 2x is 2 cos 2x, then your dx, which is from this side, isn't it? Are we together? Then you go dv. dv will remain, we have dv is exponential 2x dx. It will just remain the way it was, isn't it? So you get v is, when you introduce integral both sides to v, exponential function, remain the way it is, then you divide by the derivative of the inner function, meaning 2x, if you differentiate, you get 2, you divide by that 2. The derivative of the inner function must be a constant, isn't it? So we go back to our problem and we substitute. So go back, we have the integral of cos 2x exponential 2x dx is equals to what? A half cos cos 2x exponential 2x plus, then you put your bracket, which is there, isn't it? So inside the bracket, what do we have? We have the integral of u dv, isn't it? So if we have u dv, what do we have? Integral of u dv, you get uv, isn't it? And uv is u times v, sin times that, isn't it? So this times this, you get a half sine 2x exponential 2x. Then it is minus integral of v du. Are we together? So you can see v is this, du is this, isn't it? So v times du, 2 will cancel with the half, you remain with cos 2x exponential 2x dx, isn't it? So that is integral of cos 2x exponential 2x d. Then you close the end of that bracket. Are we together? Is that okay? See, the next thing now is to open this bracket, isn't it? Is to open that bracket. So what do you get if you open that bracket? What do we have? So it means when we integrate cos 2x exponential 2x dx, we get a half cos 2x exponential 2x, then open this bracket, positive sign does not change anything inside, isn't it? So it is plus a half sine 2x exponential, positive into negative is just negative, minus integral of this, isn't it? Cos 2x exponential 2xd. So you can see this integral is the same as, they're the same, isn't it? So this integral is the same as this, meaning you bring this one on this side of the equation, isn't it? So remember the coefficient of this is 1, the coefficient of this one. So negative 1 coming this side, it becomes positive 1, isn't it? So 1 plus 1 you get 2. So you now have 2 cos 2x exponential 2xd dx. Are we together? To be equals to a half cos 2x exponential 2x plus a half sine 2x exponential 2x. So it means when you don't have an integral on the right hand side of the equation, then you reach the end of the integration process, isn't it? So you just add your an integration constant. So you can see negative 1, when it comes this side, it becomes positive 1. So you simply factorize out a common factor. So you have 1 plus 1, a common factor. This times 1, you get what is isn't it? Then this times this one, you get that negative 1 which came this side. Are we together? So that this plus this gives you now a total coefficient of 2. But we don't want to throw into this. We want just the integral of cos 2x exponential 2x dx, meaning we divide both sides of the equation by 2, isn't it? So you divide both sides of the equation by 2, you divide all through by 2. A constant, if you divide, is still a constant, isn't it? So what do you get? You get that the integral of cos 2x exponential 2x dx is a half divided by 2 is 1 over, half divided by 2 is 1 over 4, isn't it? 1 over 4 cos 2x exponential 2x, then plus a half divided by 2 is 1 over 4 sine 2x exponential 2x plus c. So having done that, you've reached the end of the integration process. Are we together? Good. So that is how to deal with such functions which we call circulating. You just collect the like terms, isn't it? You just collect the like terms.